with this one, we want to identify what this complex number is that's right here that's graphed. Then we're going to multiply that quantity by this complex number here. All right, so with a complex graph, what we need to understand is that we have a real axis right here that goes side to side, left and right, and an imaginary axis that goes up and down. Okay, so this complex number right here goes -1 on the real axis, and it's up 3 units on the imaginary axis, so that would be -1 plus 3i. Now, if you're just writing this as your answer, you would never use parentheses here. I'm using these parentheses only because I'm going to illustrate that we're going to multiply it by this complex number. Okay, so now that we've identified this point, then we're going to multiply that by this complex number, 2 minus 4i. And I use the parentheses because we're kind of used to seeing those with some binomials. And we can FOIL this one, we can use the box method. Either way works just fine. If we take our -1 times 2 gives me -2. -1 times -4i gives me a positive 4i. 3i times 2 is 6i, and then 3i times -4i is -12i squared. Okay, well I look at this and I see that I've got common terms here, like terms we call them in math. And so I can combine these. I've got a 4i and a 6i that combined together will give me a 10i. Now, we learned this with our complex numbers and imaginary numbers specifically, that we should never write an answer with I squared because we now know what I squared equals. I squared is equal to -1. So and this is 12 times I squared, or -12 times -1. So -12 times -1 is a positive 12. Now I know I can combine my -2 and my 12 together. -2 plus 12 is 10. So now I've got 10 plus 10i. And this would be your answer. You'll write it in there. Notice I'm not using parentheses in my final answer.